Hey everyone and welcome to Toppscholars. In our previous two sessions, we have studied about indefinite integration. I hope you have gone through that video. We have also studied about the definite integrals, where we have the integration in the form of the upper limit and lower limit, and we know how to solve problems based on it. Today, we are going to talk about application of integrals. If you remember, we studied about derivatives, then we studied about the application of derivatives. In the similar manner, we are going to study application of integrals. So application of integrals is basically used to find out the area under the curve. So whatever the curve is, the area under that curve can be found out with the help of the application of integrals, right? So let us begin. So in application of integrals, firstly, what is the use of that? So application of integrals is an important concept that helps us to find out the areas and volumes. So basically, it is used to find out the areas and the volumes in various real life situations. They can tell you to find out the area of some curve, or you'll have a realistic situation as well. We'll see that based on the questions. So in this chapter, we'll basically focus on how to find out the area under a particular curve. Then we will see how to find out the area enclosed between two curves. If there are two curves, and then we're supposed to find out the area between the two curves. We're going to see that as well. Obviously, we'll use definite integrals. We need the limits, right? The upper limit, the lower limit here. So we will use definite integrals for calculating these areas, right? And then finally, we'll move on to finding out the area under the curve. So let us begin with that. So area under a bounded region. So I hope you understand what is the meaning of a bounded region, right? Suppose if I have the x-axis, I have the y-axis. This is just a random example. Suppose if I draw a line like this. So this is some line, say x plus y is equal to 5. And then this area can be called as the bounded region. It is bounded by what? It is bounded by the x-axis, it is bounded by the y-axis, and it is bounded by the line itself, x plus y is equal to 5. So this is called as the area of the bounded region, right? Okay. So let us talk about area of the bounded region. So area of bounded region can be assumed as it is composed of large number of very thin vertical or horizontal strips. So area under a bounded region. Basically what we do is whenever we have the area, now see this is a curve, right? We have something like this. And then we are supposed to find out this particular area, this area. So to find this area, is it a square? No. Is it a rectangle? No. Is it a triangle? No. So this is an uneven figure, right? So whenever we have an uneven figure, we cannot directly use the formula to find out the area. So for that what we do is, we divide this into small parts. Now what happens when we divide it into small parts? These smaller parts become rectangles, and then we add all the rectangles basically. That is what we do, no? Integration means what? We are adding them. So we add all the areas from this point A to this point B, right? And then once we keep on adding, and of course for that you need the function as well. Whatever y is equal to fx, the function will be there. So we'll integrate that, right, from A to B. And that's it, you'll find out the area under the curve. Okay. So we have the x-axis, y-axis, anyways we have the figure here. So this is our curve, right? Say y is equal to fx. And we are supposed to find out this area, the area over here. So for that, what are we going to do? We are going to divide it into small chunks. And small means very small. This is just for your understanding. It is so small that the width is almost negligible, right? So if you are considering an arbitrary strip of height y, so height is y here, and the width, as I said, is very small. The width over here is dx. In reality, it is smaller than this. So the area of this strip is nothing but integration of y dx, right? Why y dx? Because see, this is a rectangle, isn't it? And what is the formula to find out the area of a rectangle? Length into breadth. See, length is y, the breadth is dx. So length into breadth, that is y dx. And whatever this y is, whatever that function is, we'll put it there. And this total area gives us, because we are integrating, that will give you the total area, which is the sum of the elementary area. Simple. Okay, let's see. Now let us talk about area of region bounded by x-axis, bounded by the lines x equal to a, x is equal to b, and the curve y is equal to fx. Now x is equal to a, so whenever you see a line in the form of x equal to a, x equal to a means x equal to 3, x equal to 4, which is parallel to the y-axis. Whenever you have the line of the form x equal to b, again it is parallel to the y-axis, and then you have a curve y is equal to fx, right? That can be any curve. It can be y is equal to x cube, x square, that depends. So we have the x-axis, we have the y-axis. This is the curve y is equal to fx. So these are the two lines, x equal to a and x equal to b. So this is x equal to a, right, and x equal to b. This is x equal to a. Basically, this line is x equal to a, and this line is x equal to b. As I mentioned, x is equal to something is always parallel to y-axis, right? So x is equal to a, x is equal to b, and this is the area of the bounded region. This is the bounded region basically. Bounded means enclosed. It should be closed, right? Okay. So as I said, area we know it is the sum of the elementary area from a to b. So area is given by integration of a to b from a to b fx dx. So the area under a curve between 2 points can be found using definite integrals, right? We are using definite integrals here. We have the upper limit, we have the lower limit. And if a function y is equal to fx is continuous, if the function is continuous, and if it is non-negative in an interval from a to b. This is from a to b, by the way. This is from a to b, right? Okay. So find the area under the curve y is equal to x square from 0 to 2. You have fx, yes. You have the lower limit, yes. You have the upper limit, yes. You need to find out the area, which is very simple. How are we going to do that? Y is equal to x square. Y is equal to x square. Can I say it is a quadratic polynomial, right? So we can have a graph like this, y is equal to x square. And then from 0 to 2, right? X is equal to 0, x is equal to 2. So x is equal to 2, right? So this is the region that we are going to find out. By the way, this should be y is equal to 2. That is y dx, right? So from 0 to 2 x square. This is from 0 to 2 x square, right? So 0 to 2 x square. What is the integration of x square? That is x cube by 3. Then you put the values, that is 2 cube by 3 minus 0 cube by 3. This becomes 0. 2 cube is 8. So 8 by 3. That's it. 8 by 3 is the area. So the area is 8 by 3 square units. Basically, no need for the figure also. Directly you can take this curve, take the limits from 0 to 2, right? So directly take the limits from 0 to 2, and then y is equal to x square, put it here, x square dx. Simple? Okay. Now let us talk about area of region bounded by y-axis. The lines y is equal to c, y is equal to d, and the curve gy. Now how are these lines going to look like? Y is equal to c and y is equal to d. Y is equal to c and y is equal to d are those lines which are parallel to the x-axis, right? So have a look at this. So here we have x-axis, here we have y-axis. So y is equal to c and y is equal to d. Suppose this is the curve. This is our curve, g of y. This is some point c. If I draw a line parallel to the x-axis, that is your y is equal to c. And if I draw a line parallel to the x-axis again, y is equal to d. And this part, small part, is width is dy. So it doesn't matter. The elementary area is going to be, and this part is x, right? Why x? Because this is on the x-axis. So the length will be modulus of x. We'll take the positive value, of course. X dy, right? So that will be x dy. That's it. And then from c to d, the elementary area is x dy. Simple? Okay, let's continue. Exactly opposite of the previous one. There we had y dx, here we have x dy. Because we are bounding the lines by what? Since we are bounding the lines by y-axis, and the lines y is equal to something which is parallel to the x-axis. Okay, let's continue. So area, correct. As I mentioned in the previous slide as well, modulus, area is always positive. So whatever answer you are going to get at the end after substituting the values of a and b, if the answer is negative, obviously we will not accept that. The answer has to be positive, correct? Why positive? Definitely positive because area is always positive, right? Okay, let's continue. So area is given by c to d x dy or a to b y dx. So find the area under the curve x is equal to y square from 0 to 3. So if you want, you can draw the graph. Even if you don't draw it, it's not a problem. Now once you have x dy, as you know, what is x? x is y square. So you'll get y square dy. So integrate y square with respect to y, that is y cube by 3, and then put the values, that is 3 cube by 3. One of the 3's will get cancelled. 3 square minus 0 by 3 minus 0, that is 9, right? So 9 square units is the final answer. Simple working calculation. Let's continue. Now let us see some examples. These were some of the easy examples. Now find the area under the curve y is equal to 4x minus x square from 0 to 4. Now we don't have to draw anything. Directly you know area under the curve y is equal to 4x minus x square. This is our curve, right? And then from 0 to 4. So can I say this is the given curve? Area is given by y dx. But what is y? Y is 4x minus x square. So I'll get from a to b. What is a? A is 0. What is b? B is 4. So from 0 to 4, 4x minus x square dx. You can separate this, right? So integration of x is x square by 2. Integration of x square is x cube by 3. 4 and 2. Now you can put the upper limit and the lower limit. If you still want to cancel further, cancel it. This is basic math. You can do it on your own as well. Once we put 0, the second part is going to be 0 only. But once we put 4 here, that becomes 4 square and x is also 4 here. So 4 cube. We need to solve this further, of course. 4 square is 16. 16 4 is 64. 64 divided by 2 is 32. And then minus 64 by 3. 64 is not divisible by 3. So you can keep it as it is. And then get the final answer by taking the LCM in the denominator as 3. 96 minus 64. That is going to give you 32. And then 32 by 3 is going to be your final answer. So the area is 32 by 3 square units. Simple. So yes, let's continue further. Now let us talk about the area enclosed by y is equal to sine x between 0 and pi. So as you know, sine function, it moves like this, right? We are supposed to find out the area from 0 to pi. But no need to draw the graph, as we know. So this is the given curve. X is 0, x is pi, the lower limit is 0, upper limit is pi. From 0 to pi, we are supposed to find out the area. So this is what we are supposed to find out, right? So area is given by integration y dx from a to b. What is a? A is 0, b is pi. Put the value 0 to pi sine x. What is the integration of sine x? Minus cos x. So minus cos from 0 to pi. And then what you can do is you can put x as pi, x as 0. So that becomes minus cos pi minus cos 0. Minus is outside. Cos pi is minus 1. And then cos 0 is how much? Cos 0 is 1. Minus 1 is minus 2. This is minus 2, isn't it? And then minus sign outside. So positive 2 square units. So from 0 to pi, it is 2 square units. Simple as that. I hope this part is clear. So even if they tell you to find out from 0 to 2 pi, you can just double it. That will be 4, 6, 8 and so on. Anyways, let's continue. Simple question. Now let us talk about sketching linear graphs. What is the meaning of linear? Linear, where the degree of the variable is 1, of course. And the second thing is linear means straight, right? So here we are going to talk about the graphs which involve straight lines, right? Now here we put x equal to 0 to get the point where the graph cuts y-axis. Our second step is to put y is equal to 0 to get the point where the graph cuts the x-axis. In step 3, we write down y is equal to mx plus c and then find the slope. And then in step 4, we draw a graph with the help of these data, right? So let us see how to draw these actual graphs. So sketch the graph of y is equal to minus 2x plus 1. First of all, identify, is it a linear graph? Yes, it is a linear graph. The power of the variables is 1. Okay, so this is going to be a straight line, of course. How it is going to be a straight line? Let us see. We draw the x-axis, we draw the y-axis. Firstly, we put x as 0. If we put x as 0, here you put 0. 2 into 0 plus 1. Minus 2 into 0 plus 1. Anyways, this will become 0. 0 plus 1 is 1. Right? Then you put y as 0. If you put y as 0, x is 1 by 2. So y is 1, x is 1 by 2. Right? Now, y is equal to minus 2x plus 1. If we compare this with the slope form, that is y is equal to mx plus c, slope-intercept form. That is, m is the slope and c is the y-intercept. So obviously, c is directly 1 anyways, doesn't matter. And mx plus c. So m is how much? -2. And then m is -2, which is the negative slope. Then you can easily draw this line. So this is our required line, right? Now let us see how to draw a circle. Again, if you remember the equation of the circle is x square plus y square is equal to r square. If the circle passes through whose center lies on the origin. But what if the center does not lie on the origin? If the center does not lie on the origin, then equation of the circle is given by x minus h the whole square plus y minus k the whole square is equal to r square. So please make a note of this. X minus h the whole square plus y minus k the whole square is equal to r square. So firstly, we will put x as 0 to get the point where the graph cuts the y-axis. Then we will put y as 0 to get the point where the graph cuts the x-axis. And then we'll find out the radius, of course. Y-axis, x-axis is fine, but then we need to know the radius of the circle as well, right? And then we'll draw the graph with the help of whatever data we have here in step 1, step 2 and step 3. Okay, so let's begin. So this says sketch x square plus y square is equal to 9, that is x square plus y square is equal to r square. Now this is simple, isn't it? If I put x as 0, what will be y? Let me put x as 0. Y square will be 9. Taking square root on both the sides. Since we are talking about the coordinates here, not the distance, y can be negative, y can be positive. So I'll get y is equal to plus or minus 3. So y is plus or minus 3, right? So this is plus 3. This is minus 3. Okay. Similarly, if I put y as 0, x will be, this is x square will be 9. So x will be plus or minus 3, right? And then if I compare this with x square plus y square is equal to r square, can I say r square is 9, so r will be 3, radius is positive, so we cannot take it as negative. So just draw a circle within those. Once you get all the 4 points anyways, it is not difficult for you because you have got the 2 points here. You just need to draw the circle because radius anyways remains constant, isn't it? Radius is not going to change. Okay, let's continue. Now let us see how to sketch a parabola. So I hope you remember the standard equation of a parabola. We know that y square is equal to 4ax is the standard equation of parabola, right? Same thing. Put x as 0 to get the graph where it cuts the y-axis. Then put y as 0 to get the point where it cuts the x-axis. So you put x as 0 first, then you put y as 0, and then later you'll find out the focus. Because if you remember, y square is equal to 4ax, standard equation of parabola. Y square is equal to 4ax, or x square is equal to 4ay, or y square is equal to minus 4ax, or x square is equal to minus 4ay. All the 4 types, right? Upward, downward, left side, right side. Anyways, but here we are talking about parabola, so we need focus, right? Like in the circle, we needed a center. Here we will require a focus, isn't it? And then with all these data points, we can easily draw a parabola. Clear? Now let us talk about the area of a region bounded by a curve and a line. Area of a region bounded by a curve and a line. What is the difference between this and the previous topic that we studied? In the previous topic, we had the x-axis, we had the y-axis. Both of them were lines. We had x is equal to a, x is equal to b, y is equal to a, y is equal to b. Those were also lines. So we found out the area of the bounded region between the lines only. But here, what we are going to do is we are going to find out the area of the region between a curve and a line. So there will be a curve and there will be a line. So again, we are going to use definite integrals. This is obvious. Whenever you are going to find out the area, definite integrals is compulsory. So if the curve is given by y is equal to fx and the line is given by y is equal to mx plus c, then the area between the curve and the line, which forms from x is equal to a to x is equal to b, is given by integration fx minus mx plus c dx from a to b. So this is the way you find out the area of region between the curve and the line. So basically, we subtract the equation of the line from the curve. We subtract the equation of the line from the curve and integrate over the given limits to find out the area of the enclosed region, right? Okay. Now this is x-axis, this is y-axis. We have a curve. Curve is y is equal to fx. We have a line. This is some line. It can be y is equal to x. It can be y is equal to 2x. Depends. that is y is equal to mx plus c, right? And then this is the area that we need to find out. So this is the area of the region bounded by what? Bounded by a curve and a line. So this is the area of the region bounded by the curve and the line, right? Here it is. So firstly, how are we going to solve that? How are we going to find out the area? We just now saw the formula. This is again a repetition of that. We'll identify the equations first. We'll identify the equations of the curve y is equal to fx. Then we'll identify the line y is equal to mx plus c. So the curve y is equal to fx and the line y is equal to mx plus c. The second step is to determine the points of intersection. So we'll determine the point of intersection x equal to a and x equal to b, and then we'll solve for fx, which is mx plus c. And then we need to subtract, right? Put fx here, put mx plus c here, subtract it, integrate it from a to b, put the limits, get the answer. So yeah, evaluate the definite integral to find the area. Finally, we'll evaluate the definite integral to find the area as well, right? Okay. So find the area of the region bounded by the parabola. So parabola, this is what? This is a curve and y is equal to x plus 2. This is what? This is a line. So we have a curve and a line, right? So curve is y is equal to x square. Line is y is equal to x plus 2. Now let us talk about the points of intersection. So if we put x plus 2 in place of y, so here instead of y, if we put x plus 2 in the equation of the curve, we'll get x, right? See, y is what? X plus 2 is equal to x square. So x square minus x minus 2 is equal to 0. You can split this. Minus 2 plus 1. So minus 2x plus 1x minus 2 is equal to 0. You take x common, x minus 2 plus 1 x minus 2 is equal to 0. So x minus 2 x plus 1 is equal to 0. So x is equal to 2 or x is equal to minus 1. So the area will be given by x plus 2 minus x square from minus 1 to 2. Why from minus 1 to 2? Because x is minus 1 and x is 2. So from minus 1 to 2, right? And then just solve this by integrating, right? So separate it. This becomes x plus 2 the whole square by 2. From minus 1 to 2. X square becomes x cube by 3, right? From minus 1 to 2. Have a look at this. Now you put 2 here, then you put minus 1 here. Solve it. You put 2 here, then you put minus 1 here. Instead of x, of course. Solve it. So it is going to be a bit lengthy. Then after solving that, you get 8 minus 1 by 2 minus 8 by 3 plus 1 by 3. This is here. Solve it further again. So once you solve this, you are going to get 9 by 2 square units. So this particular area is 9 by 2 square units, right? Which is bounded by what? This is bounded by the parabola and the line. We had a parabola, we had a line. Again, you don't have to draw this. This is just for your understanding, right? Okay. Let us see an example now. Find the area between the curve y is equal to sine x and the line y is equal to x from 0 to pi by 2. As we know, sine x, it moves like this. Suppose if I take this as 0 and y is equal to x is like this. So definitely we need to find out this area. This is just the visualization part, which is not needed. Even if you are not able to visualize it, which is absolutely okay, you can directly solve it. So no need to worry. Let us have a look at the solution. The curve is y is equal to sine x, isn't it? And what is the line? The line is y is equal to x. So if I put it here, this is what we are supposed to find out. So sine x is the curve, x is your line. This is the curve, right? This is the line from 0 to pi by 2. Limits were already given, right? That's not a problem. So sine x, the integration of sine x is minus cos x. Integration of x is x square by 2. So this is cos x from 0 to pi by 2. This is x square by 2 from 0 to pi by 2. Solve it further. So cos pi by 2, right? Minus cos 0. And then this becomes pi by 2 square, that is pi by 4. So 4 into 2 becomes 8. And then you take the positive value, that is 1 minus pi square by 8. So 1 minus pi square by 8 square units is the final answer. Clear? Simple? So this is how you find out the area of a curve and a line, the region enclosed by both of them. Okay, let's continue. See, in the initial topic, we studied about the area bounded by lines only. Then we studied about area bounded by curve and lines. Now we are going to study about area bounded by two curves. If we have two different curves, it can be anything like this, just an example. So we are going to find out this particular area. So the area between two curves, say the first curve is y is equal to fx, second curve is y is equal to gx, over a closed interval a to b is given by the following formula. You just have to subtract the two curves, integrate them, put the values of the limits and get the final answer, right? So fx is what? Fx is the upper curve or the larger function basically. Remember, fx is the larger function and gx is the lower curve, that is the lower function or the smaller function on the interval. And a to b is a closed interval where the two curves intersect or they are between a specified limits. So the limits will already given to you. If they are not given, we will find those out, right? And then between that specific interval, we'll find out the area under the curve, right? Okay, so let us have a look at this. This is the first curve, fx. We have one more curve, say g of x. See, the blue line is g of x, the purple you can say is fx. So both of them are curves and this is the area that we need to find out, right? So all we need to do is the upper curve minus the lower curve fx minus gx integration a to b dx, right? Gx is the lower curve. So what are the steps involved? We'll identify the two curves. Identify the curves first. That is your first job. Step number 2 is, obviously we need to find out the points of intersection, right? That is x is equal to a and x is equal to b, the extreme points, the closed interval that we need to find out where the curve intersects. Then we will find out which function is above the other. Which function is above the other, that is the larger and the smaller one. We need to identify that. Then we will use this formula, upper minus lower, and then of course this is definite integral. We'll substitute the upper limit and the lower limit as well in that. And then finally, we will evaluate the integral to find the area between the curves. We'll also evaluate the integrals to find out the area between the curves here, right? So these are the steps involved. Okay, let us have a look at an example. Find the area enclosed between the curve y is equal to x square. So this is curve 1. Firstly, we don't know whether this is f of x or g of x. The second curve is y is equal to 4x minus x square. So find the area enclosed between the curves y is equal to x square and y is equal to 4x minus x square. So we have fx is equal to 4x minus x square. We have gx is equal to x square. And then firstly we'll find out the point of intersection. That is 4x minus x square is equal to y, which is nothing but x square. So this becomes y is equal to x square, y is equal to 4x minus x square. You can draw that. X is 0, it implies y is 0. If you put x as 0, y will be 0. And if y is 0, if you put y as 0, here, if you put y as 0, you get 4x minus x square is 0. So x is 0 and y will be 4, right? So if you solve this further, you get x as 4. If you put y as 0, you get x as 4. So you get x as 0, 4. Now 4x minus x square is equal to 0. If you put here x square, so 4x minus 2x square is equal to 0. You can take x common, 4 minus 2x is equal to 0. So x is equal to 0 or x is equal to 2. So here x is equal to 0 or x is equal to 2, we have got the limits, that is the lower limit and the upper limit, right? So the lower limit is 0, upper limit is 2. So 0 to 2, 4x minus x square minus x square, right? That is subtracting the two curves. This becomes minus 2x square. And then this becomes 4x square by 2. And this is 2x cube by 3. X square by 2 and x cube by 3. Put the value 2 here. So that becomes 2 square. and then 0 you can ignore. Here also 3, 2 raised to 3, 0 you can ignore. Solve it further. Here you get 8, 2 ones are 2 twos are, and then 2 fours are 8, and then 16 by 3. Solve this. 24 minus 16, 8 by 3, right? So 8 by 3 square units is the area enclosed between the two curves y is equal to x square and y is equal to 4x minus x cube. So in this session, we studied about how to find out the area under the curve. Definitely, we are going to use definite integrals. We need the lower limit, we need the upper limit. In this, we studied about when we have lines, how do we find out the area under the curve? When we have a line and a curve, how do we find out the area under the curve? And whenever we have two different curves, how do we find out the area under the curve? So that's it for today. Make sure that you also watch the video on indefinite integral and definite integral before watching the video on the area under the curves, that is application of integrals. That's it. Study with top scholars. See you next time. Thank you.